Hey everyone, let me welcome all of you back to our CAWASA Wednesday webinar. And I will do a quick intro to our guest this afternoon. And today we are pleased to have with us Mr. Bart Nelissen, who started his career as a lab tech and plant operator, followed by a decade of configuration and commissioning of SCADA systems. This experience allowed him to transition into control system architecture design, business analysis, team leadership, and project management. Bart is passionate about bridging the gap between operational technology, including SCADA systems, and information technology by providing common sense solutions. And today he's going to tell us about process control and SCADA system fundamentals. Over to you, Bart.
Well, thanks for the intro, and happy to be here. And when I was putting this together, this presentation, I wasn't quite sure what the audience was going to be made up of. And as a result, I am kept today's presentation at a relatively high level. So you're not going to end up being programmers after today. We're going to keep that for maybe the second presentation. What I am hoping to do is pique interest, and I have purposely shared my contact information, email address, and feel free if there is a question, a burning question that comes up after today. I am absolutely open to answer any and all of those. So today, at a relatively high level, we're going to talk about process control and SCADA systems. Now, what is a process control or automation system? And I guess the definition, according to Webster's, it talks about software and hardware and sensors that are designed to take on tasks of managing a process or a piece of machine. And the intent of a process control system is to do so without human intervention. And an example of a process control or automation system is a SCADA system. And that's what we're going to be talking about, of course, today. Now, why do we have those? And there's the reason we have SCADA systems is there's several. For one, safety is increased, but also operational efficiency is enhanced, and productivity is boosted, and overall accuracy is increased. Minimizing human intervention in repetitive tasks or complex tasks allows for increased accuracy. And then, of course, there's the advantage of having facilities continue to operate in the hours of the day that typical operators would not be present. So that's a real quick start of what SCADA and control systems are about. And what I wanted to cover today is the different components that make up a SCADA system. We're going to get into a little bit of detail on that. And then closer to the end of this, I'm going to talk a little bit about design considerations of control systems or SCADA systems, and life cycle, which is often a forgotten topic. So I do want to raise a little bit of awareness for that today. So with the levels of a control system, let's talk about the components. Here's a complex picture, and it makes up the 4 levels of a SCADA system. And I'm going to go through this from the bottom up. So at the bottom, we are looking at the facility, the plant, and the devices that are on the plant floor that are on your process equipment. And those devices, instrumentation or local devices, are physically connected to a controller. And a controller is an all-encompassing name for more specific things called a PLC, which we're going to get into in just a moment. And a PLC is connected to an architecture or a network, a communication type level. So that communication is the 3rd level of a SCADA system. And that can be a variety of all sorts of different things. And the 4th level of a SCADA system is the actual interface, the supervisory control. And we'll talk a little bit more about all of these levels here in a sec. So these are the 4 levels. The first one being the one that is at the process at your facility at the plant floor. So now we're talking about that field equipment. And that field equipment can include things like valves, motors, pumps. The device that is on the bottom left, the black box, is a device that allows motors to run at variable speed. So it's any and all of these devices, including things like a temperature sensor, or maybe a level measurement sensor, or could even include things like a float in a wet well. All of those types of devices are physically on the plant floor, monitoring or controlling your process. And they are physically connected to that third level, which was the controller. But one thing I wanted to point out is that it's of the utmost importance to make sure that configuration of devices that are on the plant floor, that configuration lines up with the configuration in the rest of the control system. And the configuration, for example, could indicate a level of a water reservoir. And the configuration would have to make sure that, for example, we're displaying that level from 0 to 100% consistently through all the different levels of the control system. Because if somewhere along the lines your level measurement device, for example, registers percent, and somewhere along in that process, in the different layers, that gets translated into inches, then things don't look right. So inaccuracies are of the most importance here. And as a result, if any instrumentation or any device or any measurement sensors at the plant floor get either replaced or calibrated, it's very important that that goes hand in hand with the configuration of these devices in the other levels of the SCADA system. So that's the bottom level. At the plant floor, the controls and monitors your process. Now, each and every one of these devices that are sitting at the plant floor are physically wired to the local control level. So this picture now depicts that, where each and every one of these 3 examples are physically wired into what's called a PLC.
Excuse me, Bart, are you showing some slides?
Yes, I am.
No, we're not seeing your slides.
Is that right? It says here that I am screen sharing.
No, I'm not seeing that.
Were you able to see the very first one?
Yeah, you had the very first one, but which was the very first one was showing the title, but it wasn't showing you. Yeah.
Okay.
So I didn't mean to rudely interrupt you. Sorry about that.
No, I'm glad you did. Let's see if I can.
Oh, you seen the slides? Somebody said they've seen the slides, so maybe it's me. Okay. Well.
Yes, we've actually seen it.
Oh, you've seen it. Okay, go ahead. Go ahead.
Okay.
Go ahead. All right.
Yeah. Please drop in the chat if there is an issue. I see slides. Thank you, Kevin. Thank you, Karen. Okay.
Yeah, great. Okay.
If anybody has challenges, please, yes, pipe in. Thank you. All right. Where were we? We were talking about the levels of the control system where every device at the plant floor is now physically connected to a controller, to a PLC. And we're going to get into that in just a second of how that works. But what's important to note here is that controllers, like a PLC, they monitor and control the devices on the plant floor. And that's why the arrows are going back and forth, up and down, because that's a two-way communication. Writing to and reading from, monitoring and controlling. Now, how these devices are being controlled is done through a program, and that program operates within the PLC. And that program is written based on what's called control philosophies or control strategies. And those are documents that would have to come from your design engineer. So your design engineer who lays out the facility and designs all of that would have to generate the documentation that is then handed to a programmer so that the PLC can be programmed and can interact with all the devices at the plant floor as intended. So that's that PLC, or that local control level. And when we connect that to the third level from the bottom, we now start talking about the communication infrastructure. And the communication infrastructure is, or can be, a mix and match of all sorts of different methods of communication. And that's actually where SCADA systems excel, because we can have various facilities that are spread out through a municipality, for example, all communicating to one centralized interface, which is that last layer, which we'll get to in a moment, through all sorts of different communication methods. So SCADA systems are really good at interpreting that data, enabling communication, and presenting the data in such a way that it's all transparent behind the scenes. All that technical side of communication is hidden, and all the data is presented in a very user-friendly method. So when we start talking about controllers and how to connect those, we can talk about the PLC itself, but we can talk about remote sites. And we're going to get into a couple of examples of how and what kind of communication in just a second. But altogether, the communication layer brings all the data from all the different PLCs and controllers together into that supervisory control level. So that's that fourth level. And this is where graphics are generated using software, and they provide that SCADA functionality, supervisory control, and they collect data. And that's the data acquisition. The last two letters out of SCADA is data acquisition. So they log data that can be used for various reasons and purposes after. So this supervisory level, the fourth level, is a combination of hardware and software, where all of the data from all these different facilities and all these different PLCs can be brought together and presented in a user-friendly interface. Now, there's a lot of talk, and in my bio, my introduction, just quickly, it was mentioned that IT and operational tools are sometimes working together. And as you can imagine, with communication and computers, software, and hardware, we often work together and use technology from an IT or an information technology type discipline in the rollout of a SCADA system. But what I wanted to make sure is that the SCADA system is an operational tool. It's a tool that operations are using to monitor and control their critical infrastructure, their facilities. So those are the four different levels of a control system, of a SCADA system. We've got the plant floor, we've got the devices on the plant floor, I should say, then we've got the PLCs, the controllers, the communication, and then that supervisory interface. Now, if we break this down a little bit and start talking about how the data from a device on the plant floor is coming into a PLC. So now we're talking about the connection at the bottom right of this picture of a device on the plant floor coming into a PLC. And traditionally, there are two different ways that that can happen. One is what we call an on-off type signal. And that could be a discrete, we call that a discrete signal. And that only allows for two possible states. So either the signal is on or it's off. So think of a light switch. It's truly as simple as that. You're either have a electrical circuit or you don't. And the other way that traditionally process equipment communicates with a PLC is what we call analog. And an analog signal has variable states, and it can most easily be seen or compared with a dimmer switch, which I think we're all familiar with. So having a dimmer switch on your light or above your dining room table is very similar to what we call an analog signal in process control in SCADA systems. And with these analog and discrete type systems, we have, and I think I mentioned earlier, the inputs and outputs. We have monitoring and controlling of these devices out on the plant floor. So that's what we call these. In the world of SCADA, we call those discrete inputs or discrete outputs. And a discrete input would, for example, be a device, a sensor that's out on the plant floor where we are monitoring its state. So that could be, for example, a float in a wet well or in a water reservoir. And then we have the analog. The analog signal also has an analog input or an analog output. Oh, by the way, I mentioned an example of a discrete input being, for example, a float that tips. A discrete output, an example of a discrete output could be a start command, where you send from an interface a command to start a pump. Now the analog, same thing. We have an analog input and an analog output. And an analog input would, for example, be a transmitter that measures a variable level within a reservoir. Or an analog output could be the speed setting on a pump. So once again, discrete input, discrete output, analog input, and analog output. Those are the traditional signals that a PLC will monitor or use to monitor or control devices out on the plant floor. So what that looks like in PLCs or controllers is something like this. A PLC, which I think stands for Programmable Logic Controller, is a device that gets wired physically to all the devices out on your instruments out on your plant floor, your sensors, etc. And it is capable of monitoring the inputs, analog and discrete, and it is capable of controlling the outputs, also analog or discrete. And it's got three main components in a PLC in order to do that. The first main component of a PLC is what we call a CPU. That is called a central processing unit. And that's really the brains of your PLC. That's where the program resides that is written by a programmer. And that's what actually performs all the logic. Then we have the modules. And the modules are called I/O modules. And the I stands for input, and the O stands for, you guessed it, outputs. So I/O modules are the components of a PLC that are physically wired to the devices out on the plant floor. And then there is a module, a component of a PLC that is called a power supply, which actually is the one that would generate power and enough power and proper power to power up outputs. So when we, for example, say the PLC turns a light on, then we need to provide power for that light, and that comes from the power supply. So those are the three different components of a PLC. The central processing unit, which is the brains, the modules for all the inputs and outputs, and the power supply. The beauty of a PLC, before I move on, is that a PLC can be put together based on the needs and the instrumentation and all the devices out on the plant floor. So if you have a lot of discrete measurements, a lot of discrete control, then you can purchase and put together your PLC with mostly discrete modules, input and output modules. That's where a PLC excels, and it's very scalable. So if you add a module, that's never a problem. You can add facilities or expand your facilities. You can add the devices on the plant floor and expand your PLC. Now, there's another device, also a controller, that basically does the same thing, and it's called an RTU, or a remote terminal unit. Now, those are devices that are designed for smaller instances, for maybe a lift station or a water reservoir or a pump station, where there's not that much from a process perspective going on, and capable of handling fewer inputs and outputs. So in a nutshell, that's what an RTU does, a remote terminal unit, or sometimes called a remote telemetry unit. Typically in the world of plants, wastewater and water type facilities, we talk about PLCs. So that's that second level, the controllers itself. So once again, the controllers, the PLCs, they will monitor inputs. They then execute their logic within their CPU, and they control outputs. Now, those PLCs are connected through some sort of a communication infrastructure, and that can be a variety. And I've listed a couple of examples, but there can be many, many, many more. And you can mix and match. You'll have typically on a SCADA system, for example, in a water type setup, you might have pump stations, PRVs, water reservoirs, wells, what have you, all connecting from all these different sites into a centralized SCADA solution. And all of these may have different mechanisms of getting that data from a remote site into the centralized SCADA system. So we can use hardwired internet, which is potentially the same as what might come to somebody's house or business. We can use cellular technology, because cellular, just like your smartphone, allows for data to be transferred. Ethernet, if you are in a facility, a very common method of connecting different process areas is through Ethernet. And I think we're all familiar with Ethernet because we often use that even at home to connect your printer to your computer. Serial is an example of a bit of an older type communication, but it certainly is still out there. And legacy devices or legacy SCADA systems are absolutely still using a serial communication architecture. Radio for data would be not necessarily the same type of radio you have in your vehicle, but just strictly data radios. They can be advantageous because once you have installed a radio, you can transmit and receive as much data as you want, and you would never get billed for that anymore, which is different with an internet or a cellular type connection. But radio also has drawbacks because radio would require what we call a line of sight, which really is a clear, unobstructed path between the two sites that you're trying to connect, which means that you cannot have hills in the way, you cannot even have buildings in the way, and most times you can't even have trees in the way. Satellite, for those pesky type locations that are hard to cover with maybe a wired internet or maybe even cellular, satellite can be a fabulous solution. And the cost of satellite is actually coming down very quickly. So it's a very viable method of communicating with remote sites into a SCADA system. And then there's the Internet of Things. Now that could actually be almost a presentation on its own to cover what an Internet of Things architecture might look like. But Internet of Things, it is enabling the internet hosting service to sit in between two sites, which is something that we're very common with. Because if you use your smartphone and your Snapchat to text with somebody, then you don't actually physically connect your smartphone with your friend's smartphone through Snapchat, but they actually go through a hosted service from Snapchat. And that's an architecture that has become very common within the world of internet use. And we are now actually deploying that in process control and SCADA systems. So if there's interest, and by all means, feel free to let me or the organizers of CAWASA know. If there's interest, I can absolutely present and talk about Internet of Things and process control in the future. So the I guess most important piece of this slide, of this communication infrastructure to remember, is that SCADA systems are very good at mixing and matching all sorts of different mechanisms together. And at the end of it, they will all be presented on a SCADA system, as in the interface. So the SCADA interface, once again, SCADA stands for Supervisory, Control, and Data Acquisition. That's actually a little bit different than the other term that we use for an interface in process control, which is called an HMI. An HMI is a more simplistic type interface. And I put a picture on the slide here of a little panel that is sitting in the front of a control system type junction box or control panel. And the intent of an HMI is that that little interface, often a touch screen these days, is only capable of communicating to the controller that is inside that box. And that's the biggest difference between an HMI and a SCADA system interface, because that communication layer that we just covered brings all of these different sites and all of these different PLCs together, which an HMI is not designed to do. So that last layer, that top layer of those four, that interface is completely designed to provide a user-friendly interface for operations. So what functions does it have? Well, there's typically four, and these four are, like I said, the user-friendly interface. So it's a visualization tool. And with that, we generate graphics that mean something to an operator. And the intent of this is to give the operator as much information that he needs in a logical manner. Now, that varies, obviously, and a lot of this is dependent on personal preference. But that too, we can talk about in a little bit more detail down the road. The second function of a SCADA system is alarming. And not only just to enunciate or show an alarm, but it also is capable of notification and broadcasting that alarm as it needs to. So if, for example, we are talking about a water treatment plant that is only manned, during regular business hours from 8 to 5, and after hours everybody goes home, it is the SCADA interface's function to broadcast the alarm to an operator after hours so that an operator still gets the alarm and can take corrective action. Now, how that alarm gets broadcasted, there's several options for that. It can either be a voice type phone call, or it can be an email, it can be a text message. The third function of a SCADA system is process control adjustments. And this is where an operator would, for example, turn equipment on, open a valve, turn equipment off, or change a set point for process pressure or level type control. So process control adjustments is the third function. And the last function of a SCADA system is that data collection piece. Remember, the last two letters out of SCADA stand for data acquisition, and that is what it's all about, is to store that data into files so that it can be used in the future for things like reports or trends. Now, Examples of why a report or a trend could be of value, well, troubleshooting. If something went bump in the process, it's of the utmost importance that an operator can review what happened and figure out what to do so that it doesn't happen again, or to then analyze the conditions that led to the process upsets and then make process control adjustments, which is the third function that we just talked about, to take those corrective actions. Reports can be generated from a SCADA system, and they can either be Excel files or they can be a PDF type of report that can be either printed on a regular basis or it can be emailed. And reports, they can be of great value because they can be tailored to its audience. And what that means is that your maintenance crew might need a different report than upper management of your facility. So your maintenance crew can get a report on a weekly basis so that they can start compiling runtime hours, for example, and do preventive maintenance, oil changes, etc. Where maybe your upper management is a lot more focused on the cost and chemical use and associated cost of it. Not to forget, another function and reason that reports can be of great value is compliance. Because with the proper reports and setting those up with the proper parameters and using the data that is being collected by a SCADA system, you can trend and show and generate the reports to make sure that you have the proof that you are within the compliance, within the regulatory requirements. So those are the four different functions of that fourth level of that SCADA system. So once again, we have the devices on the plant floor, we have the PLCs or the controllers, we have the communication infrastructure, and then we have that interface. And with that, I am going to now switch gears a little bit because those are the four different components, and I'm going to start talking about design considerations of a SCADA system. And I've put four on the screen, and I also put a picture on the screen of what an, may I say, older style process graphic looks like. And I say older style because more current guidelines in the industry have indicated that graphics, such as what you're looking at right now, being very colorful and very busy, are not necessarily the most productive graphics for an operator to use. And the reason why is because it is too cumbersome and too hard for an operator to determine what's right and what's wrong on this graphic. So there's current industry trends where, if you recall the previous slide, which was a very boring almost and grayscale graphic, the colors on those grayscale graphics are reserved for alarms. And that's a trend that has come up in the last number of years. And this is an international trend, I might add, where colors are reserved for for alarms, so that when there is something happening that is out of the ordinary, the color on the graphic jumps out at an operator and it's easily seen. And as pretty as this process graphic might be that you're looking at right now, it has proven not to be the most productive. But back to the design considerations. The first design consideration that really needs to be kept in mind when you start thinking and planning for a SCADA system is the degree of automation. Because just because you can do something doesn't necessarily mean that you should. And maybe all of these colors on this graphic is an example of that. So you have to define what you want, and you have to define what you absolutely must need. So that's that degree of automation. Then you have to define and design the functionality. For example, I put four examples here. One is redundancy. So if you have a critical infrastructure type facility, maybe it makes sense to have a backup SCADA server so that you have a primary that is typically used, but if the primary SCADA server would fail, so if that computer fails, that you have a backup and you can continue to operate your facility. Security is a big one. And we read so much more about that these days, where the energy and the utility sector, the one that we are working in, is actually the third highest target for what's called ransomware. And that's not necessarily alarming, but it's certainly something that means that we need to keep security on our radar. We have to make sure that our SCADA systems are secure as possible. And especially when we start talking about using the communication infrastructure such as the internet or cellular, because that is using a internet, therefore has to be architected and planned to be secure. Now it can be done, but it needs a little bit of planning. The third example that I used listed as part of the functionality that needs to be determined early on is remote access. And remote access could be for operations if your facility is not manned 24/7, but remote access can also be used for somebody that provides SCADA support. We currently, as a SCADA tech, we do this all the time for our current clients, and it doesn't matter where they are in the world. We can remotely connect to their SCADA system and help them troubleshoot issues should they arise. And then the last bullet that I put under functionality is emergency situations. So I put that on there because when you design a SCADA system, it is of utmost importance to think about how you can use your SCADA system in case of an emergency. So what if you have to evacuate your control room or your public yard office or your water plant where your primary SCADA server sits? Or what if it gets compromised by, God forbid, a fire? Maybe your backup SCADA server should physically not be sitting right beside your primary SCADA server. Because if your primary SCADA server becomes unavailable for one reason or another, your backup SCADA server, which might be sitting across the city, will still be up and running. So that plan and that design is of utmost importance and certainly should be considered in the design considerations early on when you start thinking about rolling out a SCADA system. The budget, obviously, is extremely important as a design consideration and certainly plays a role in the selection of products and may even play a role in that first bullet, the degree of automation and defining what you need and what you want. And then the last bullet I put up is, as part of the design, the communication infrastructure should really be planned out so that communication is designed early on with the proper devices and the proper architecture, and also then maybe sets up the SCADA system for that remote access. Now, when we talked about remote access, we typically include not just operations, but also other parties. For example, maybe your municipality has an in-house engineer that would like to have access to do his job to the SCADA system. Or maybe you can rely on a third-party consultant or your engineer that is out of your municipality, or your engineer that provides support to your SCADA system, or maybe even your regulatory authorities. So those are all considerations that I believe should really be considered early on in the design of a SCADA system. And then before we start getting near the end of today's presentation, I wanted to talk about the life cycle. And as strange as it may sound, but even at the moment when you start designing a control system or a SCADA system, you really have to plan for the life cycle and the fact that a SCADA system needs maintenance and it needs upgrades and replacements. For example, the PLCs, the controllers, they typically have a lifespan where they will be supported and operational for 15 years. And that sounds like a long time, which it is. My point is that if you don't plan for that 15 years, then 15 years from now, you are going to be looking at major cost and a massive impact to your operation to upgrade those controllers. And that's currently what we're doing. In our industry, we've noticed that a lot of our users, a lot of our municipalities haven't planned for these upgrades. And when the controllers start failing or they are no longer supported by vendors, it becomes a big challenge to maintain your critical infrastructure on those controllers. So plan for about 15 years. Now, I listed a battery here as a separate topic simply because of the fact that the battery that resides within the controllers, which, for example, would hold your program in case there's a power failure, that battery should be replaced yearly or every 2 years just to make sure that you're not going to lose your program when the power comes back. So that's on the controllers, on average, 15 years. But your SCADA host or your SCADA interface, which is running on a computer or a server of some kind, has a much shorter life cycle. And the recommendation is to replace that computer every 5 years. And it's probably no different than the computers that are used by all of us to do our daily jobs. So plan for a 5-year life cycle on the hardware, where the software may even be less than that. The software license for a SCADA product can often be purchased with a support agreement, which allows the users to stay current with the product. And we certainly recommend that. At the end of the day, we urge our users to maintain a common off-the-shelf product, to not generate a unique solution. So as far as life cycle is concerned, highly recommend to plan for upgrades, no matter what stage you're in. And in summary, as I'm getting to my last slide right now, that SCADA system that may be very complex is made up out of 4 different levels. We've got the equipment on the plant floor, you've got your PLCs, you've got your communication, and you've got your SCADA interface. The design early on in the project is a very big deal. So consider those bullets that I put on the slide and plan for upgrades. And it doesn't matter if you are new to this, if you have a SCADA system that has been up and running forever, or if it's a SCADA system that is just in the design phase. I highly encourage you to start thinking and planning for upgrades, and maybe even set a budget aside for the upcoming years so that when the upgrades are inevitable, that you're not going to end up with a massive capital project that needs to be spun off. Thank you for your time, and I'm absolutely open for any questions that anybody might have. And with that, if there's any topics that I may have covered very briefly and very quickly that anybody may be interested in hearing more in the future, absolutely bring those up. Feel free to put them in the chat or present those to the organizers, and we can see what we can cover in the future.
All right, thank you very much, Bart. You said it was going to be so complex, and I think it just whetted our appetite to get more complex. But thank you so much for that great elucidation about SCADA systems. I trust that we should have some questions from the participants. Feel free to put in the chat, or you can.
I should mention, Ignatius, that Bart is actually, because I see we've got Anderson and maybe some other people from Barbados. Bart is going to be delivering SCADA workshop, a 2-day workshop in Barbados in the next few months.
Brilliant. Yeah. Jay Jones, you have your hands up, please.
Hi, good afternoon all. Thank you for the presentation, Mr. Bart. I'm from the Water and Sewage Corporation in the Bahamas, and I also assist in overseeing our system control department, which is inclusive of our SCADA team. I had a few questions. The first one, certification for operators. what do you suggest, or where do you suggest we go to seek this for our operators?
Where you can get certification for your operators? Is that what you're asking?
Yes.
That's an interesting question because from an operational perspective, where I operate here in Western Canada, it's provincially regulated, and I cannot speak for your geographical area. Now, when it comes to SCADA systems, it's funny, but there is no certification requirements. The engineering discipline even is one that doesn't necessarily exist for the programming and the certification of control system engineers and technologists. So I'm not even sure if I can honestly answer your question satisfactory. I'm sorry.
Yeah,
Okay, thank
perhaps I can a bit. And if you're in the Bahamas, I think Mr. Gibson has been liaising with us at CAWASA.
Yes.
Since we do the certification, we offer the certification program. We're the principal agents for the Caribbean region for the Water Professionals International Certification Programs, as well as the Professional Operator Program.
Mhm.
So you can always inbox me or send an email and we can follow the discussion there.
Are you able to put your email in the chat? Mr. Gibson is aware, and I think he was
Yeah.
out to
Yeah.
someone regarding that.
All right.
And my other question is, I guess, what are your recommendations for SCADA programs? And currently we're using BTEC.
That's a great question. And it's almost the same type of question as what kind of car do I recommend? But it really depends on the requirements, because if you have 7 people that you need to move every day versus only yourself, or if you have to move a load of dirt every day versus no luggage, it really depends on the requirements. So as part of the design considerations, having upfront conversations to define these requirements is, to me, the critical phase required to decide what products are best suited.
Understood.
And to follow on from that, Bart, is that something that if you knew all the specifications, you could perhaps, give some advice rather than leaving?
Absolutely.
Yeah, so Operators Without Borders, like Bart is one of our volunteers, and his company is supporting Operators Without Borders as well. So if you, sort of are looking at something or needs just some independent advice rather than just talking to salespeople, we'd be happy to help.
Yeah, I have been doing this SCADA work. I was actually thinking about this in the shower last night. It's been actually 30 years, believe it or not. And I've always been vendor neutral. So I've been exposed to a large variety of different products in the industry, and absolutely happy to help define and spark some of these conversations that will lead to your requirements and then support you in a product selection.
Thank you.
All right, great. Any other questions or observations you wish to share with Bart?
Hi, good afternoon.
Good afternoon, Timothy.
Augustus here out of Trinidad and Tobago, professional operator. And of course, I know you would have left out a lot of the other components for the SCADA system. Is it that we have a lot of sensors and monitors and that would give feedback information, but many of these things go bad faster than a 5-year period. So my question is dealing with the type of course we would have to look forward to in putting such a system in place.
Sorry, I heard you say that your devices out on the plant floor appear to be lasting less than 5 years.
No, what I'm saying is the upgrade. I noticed that you said that the upgrade would be a 5-year period in terms of the actual controls system. But we have a lot of other sensors and monitors and probes and devices that would, go bad within probably a few months, or would probably need a lot of cleaning and replacement in order for the whole system to work properly. So in terms of a cost, is there an idea of what that would look like? Because many agencies would purchase a SCADA system and not understand that the operators also have to do a lot of work to also monitor the system.
I see. So what I have been talking about is the devices that physically connect to your instrumentation and the equipment on your plant floor. And I am not an expert on the actual devices, the sensors, and those items that you're mentioning that are giving you grief on a regular basis. What I can tell you is that a SCADA system is often limited by the devices that are out on the plant floor. And even if you replace the SCADA system with a more modern or current version of it, you're still limited to the exact same devices, the instrumentation and the equipment that's out on the plant floor. So it sounds to me that that might be your limiting factor that needs a little bit of work and planning so that the operation and the maintenance of it is not as cumbersome as it sounds it is. But once again, I'm more on the control side of things, the process control, the automation, the SCADA, not necessarily on the instrumentation and the devices. In our companies, we have electrical engineers for the MCC type setups, and we have instrumentation engineers for the devices that I think you're inquiring about.
Okay, Bart, we have two questions in the chat. One is, are you available for companies who are interested in upgrading the system? And does this come with physically replacing different components like sensors, etc., around the plant?
That is an excellent question. And yes, I am available for companies interested in upgrading a SCADA system, and that being either a PLC or the SCADA interface. And replacing a PLC or replacing a SCADA interface does not require any changes to any of your process equipment. So your pumps, your valves, your level indicators, your transmitters, your switches, your floats, none of that would change. Those are currently wired into a PLC, and we would use that exact same wiring to disconnect from an old PLC and reconnect that to a new PLC, for example.
The second question is, given the emergence of blockchain technology and its variety of uses, how do you see it fitting in with SCADA systems?
I have in the past presented on the future of SCADA, and I think that this is a question that would fit quite well into that subject, that topic, because absolutely it's a new technology that is being used. And I briefly mentioned the Internet of Things. Yes, we see an expansion of SCADA technology that we are using or that we can use. The traditional SCADA mechanisms are not going anywhere. So I see emerging technologies as an expansion to what we currently have.
Okay. I don't see any new ones in the chat. Are there any other questions you may want to chime in on your microphones if you wish? Going once, going twice. Gone, gone, gone. So thank you very much, Bart. And thank you, Valerie, for another very good, excellent find this afternoon. And I think, as I said, it would have whetted our appetites for more of this. And
I think maybe in the fall we'll bring Bart back to talk on more complex issues.
I'm pleased to know as well that he is heading to Barbados soon to have some further discussions with the operators at the Barbados Water Authority.
Mm-hmm.
So that's
looking forward to it.
And perhaps we may be able to continue some conversations around that with other utilities in the region. So thank you very
Yes,
much.
certainly.
Thanks for the opportunity.
Right,
Yeah,
great.
but Bart has just joined our Operators Without Borders family, and we're really excited to have his skills and abilities joining us. So they'll be available to your operators and your utilities.
Yeah, brilliant. Okay, well, I'm Ignacio Ja, the Executive Director at the Caribbean Water and Sewage Association, CAWASA. Thanking all of you for joining our Wednesday webinar. This was webinar number 8, and we look forward to seeing you next week. And I'm signing off. Have a good evening, everyone. Bye-bye.
Good
Thanks,
evening.
everyone.
Thank
Thank
you.
you.
Thank you.
Thanks, Bart.